डियर स्टूडेंट्स, आज का जो हमारा लेक्चर है वी आर गोइंग टू डिस्कस वन मोर प्रॉब्लम ऑन दिस Lagrangian dynamics. So the today's problem is that the Lagrangian of a particle that is given by L equal to 1 by 2 mx dot square plus y dot square minus that m omega square by 2 x square plus y square. तो ये हमारा Lagrangian है. तो now the condition is given here. So at time t equal to 0. So initially when the time t equal to 0, the coordinates x and y are, so x equal to 0 and that y equal to y naught. And the corresponding velocity at t equal to 0. So that is x dot equal to y dot, that's equal to v0. So this is our initial velocity. तो हमें क्या करना है? We need to calculate the angular momentum of a particle at time t. तो हमें angular momentum calculate करना है. So that means we know from our we know the so mathematically how we can write this angular momentum, that is equal to m into r cross omega. So that means मुझे calculate क्या करना है? मुझे Gaussian vector calculate करना है. I need to calculate r. So that r will be equal to, that is xi cap plus yj cap, right? Because the motion is in the plane, right? Because only the x and y coordinates are mentioned here. So that means हमारा जो particle है it is in the plane. तो हमें जो हमारा position vector होगा, so that will be xi cap plus yj cap. And similarly we need to take its cross product with the velocity. So that means similarly the velocity has horizontal as well as the vertical components. Okay. So so how we can solve this problem? So that means हमें calculate क्या करना है? So we need to calculate the angular momentum, because we know that the angular momentum equal to angular momentum. So that is equal to L equal to, that is m into r cross v, right? But what's our r? तो जो हमारा r है, so that is xi cap yj cap, and our v equal to, so that is vx I cap plus vy j cap. So what does it says? So that means हमें calculate करना है what are our corresponding x and y and what are our corresponding vx and vy. But the condition is that at t equal to 0, तो condition इसके लिए दिए है what is our x and y coordinate, velocity क्या हो गया इस point पे. So we need to use this condition, and with the help of this Lagrangian we will calculate what's our r and what is our v. So first of all, so again I am basically saying that the particle here, if you see here, the particle will execute that simple harmonic motion, because this is so we have discussed earlier one problem. So we have same Lagrangian there, तो वहाँ पे भी Lagrangian same था, but instead of that m omega square there was that supreme constant k. So that means k is here, that is m omega square. So that means our frequency will be square root of k by m, right? So let us first calculate. So we will again use that the equation of motion. So calculate first what's our that x and y from here. Okay. So let's first, so from equation of motion. So from equation of motion, I can write that partial L upon partial x dot, and what's my partial L by partial x. Okay. So first I will calculate that what, because Lagrangian equation is that is d by dt of that partial L by partial q dot minus that partial L by partial q. So q is here x. So first I need to differentiate this Lagrangian, because जो हमारे Lagrangian है, so it is 1 by 2 mx dot square plus y dot square plus minus this term. So first when I calculate what's my partial L by partial x dot, so ये हमें यहाँ पे क्या देगा? It will be minus, that will be twice m x dot divided by 2, because we need to differentiate it partially with respect to x dot. तो यहाँ पे क्या आएगा? It will be mx dot. तो यहाँ से आएगा mx dot, and the second term Now I need to calculate what is my partial L by partial x. So partial L by partial x is, so that will be minus m omega square, because when I differentiate this, when I take this Lagrangian and differentiate it partially with respect to x, because so this term will be, so this will be constant here, so its differentiation will be 0. So only this will vary. So that means this will be twice m omega x, twice m omega square x divided by 2. So this will be minus m omega square. So I will get here minus m omega square, because 2 will cancel with this one. Huh? So this is for when I calculate, when I differentiate this Lagrangian partially with respect to x dot and with respect to x. And similarly, if I take this Lagrangian, so I can calculate what's my partial L by partial y dot. Partial L by partial y. Because जो हमारा Lagrangian है, so that is equal to y dot square minus m omega square divided by 2 into x square plus y square. So that means now I will differentiate this partially with respect to y dot. तो यहाँ से क्या आएगा? तो यहाँ से आएगा simply that is m y dot, and partial L by partial will be, that will be minus m omega square, because sorry, so I can, so I should write here also y here. Okay, so there was a mistake. So in previous, so I can also write here m omega square x. Okay, that's right, because the differentiation of, when I differentiate it, it will be twice minus twice m omega square x divided by 2. So this will be minus m omega, because 2 will cancel with this thing. So you can write then, so it will be, this will be equal to minus m omega square x. Okay. So let us now write now what's our Lagrangian equation of motion, because I have calculated both the things. I differentiate that Lagrangian partially with respect to x and x dot, and with respect to y and y dot. So let's calculate from, so we know that, so now our Lagrangian equation of motion. Okay. So our Lagrangian equation of motion will be, or I can erase this because it is okay. So we can derive this. So our Lagrangian equation of motion will be, that is d by dt of partial L by partial x dot minus partial L by partial x equal to 0, and second equation will be, so that's equal to 0. Huh? So I have two equations from Lagrangian equation of motion. Now let's calculate from here, because हमने already calculate किया what's our partial L by partial x dot. So let us first calculate this. So first to solve this equation, first equation, and similarly I can write for the second equation. So first, so from here I will write that d by dt of, so this will be m x dot, because you can check that, so that partial L by partial x dot is mx dot, and partial L by partial x is minus m omega square x. So that means I can write here minus into m omega square x, that's equal to 0. Or this will be equal to mx double dot plus m omega square x equal to 0. Or you can write that m into x double dot plus omega square x, that's equal to 0. So that means from this equation either m equal to 0 or this term is equal to 0. But m cannot be equal to 0. This is the mass of the particle here. Mass of particle cannot be equal to 0 here. So that means m cannot be equal to 0. So from here I can write then x double dot plus omega square x इसके बराबर आएगा, that will be 0. So that means our first equation will be, that is x double dot plus omega square x, that's equal to 0. And similarly, so I can write that y double dot plus omega square y, that's equal to 0. Because when I take this equation, तो अगर मैं दूसरी इक्वेशन सॉल्व यहाँ पे करूंगा, so there I need to take what's my partial L by partial y dot, तो वो हमने ऑलरेडी कैलकुलेट किया है, that's my dot. And similarly हमें पता है what's partial L by partial y, and we substitute these two values in this equation, so I will get this equation. So that is y double dot plus omega square y, that is equal to 0. So let's now we have two differential equations. So the solution for this differential equation will be, because it will be oscillatory, so it has that, it can be a combination of that sine wave function plus cosine wave function. Right? So if I write the solution for this, so I can write that x will be equal to some constant a cos of omega t plus b sine of omega t, and my y will be equal to, so let us label some different constant here. So this will be equal to c cos of omega t plus d sine of omega t, because these constant, so amplitudes can be different here, right? Because this is the solution for the first differential equation, that is x double dot plus omega square x equal to 0, and similarly for the second equation. Now let's have a look on the problem. तो जो हमारी प्रॉब्लम है, तो हमें कैलकुलेट करना है एंगुलर मोमेंटम, एंड प्रोवाइडेड, सो वी आर प्रोवाइडेड विद द कंडीशन, तो हमारे पास कंडीशन दी गई है. सो कंडीशन जो है एट टाइम t इक्वल टू 0, जो हमारे x एंड y कोऑर्डिनेट्स है, सो x इक्वल टू 0 एंड y इक्वल टू y नॉट. एंड सिमिलरली जो वेलोसिटी कंपोनेंट्स है, that horizontal and vertical components of velocity, so that's x dot and y dot, that's equal to v0. तो हमें ये कंडीशन यूज करनी है to calculate what should be the angular momentum at time t, right? So this is our question. Okay, let's go back to our main slide. तो हम यहाँ पे देखेंगे अब, so how we can solve this, because I can use this condition now. So according to condition, so according to the condition, or you can write that according to question, according to according to question. So question says that at t equal to 0, अगर मैं टाइम t 0 के बराबर लूंगा, so my x equal to 0. So let us first solve this equation. Right, so I have two equations. So this is equation number first, and this is equation number second. So let us solve equation first. So at time t equal to 0, हमारा x 0 के बराबर, displacement along x is 0, right? So initially at t equal to 0, x equal to 0, so I can write that 0 will be equal to, so that is equal to a, because when I put at t equal to 0, sine of 0 will be 0 here, so multiplied by b, so this again 0. तो अगर हम मैं फर्स्ट टर्म यहाँ पे देखूंगा, because cos 0 equal to 1, so that means a equal to 0. So let us substitute that a equal to 0 in this equation. So when I substitute it in this equation, so I can write that x will be equal to, so that is b sine of omega t. So this is clear, right? Because I put that condition at t equal to 0, हमारा x 0 के बराबर आता है, right? So because why I am doing this thing, because I need to calculate angular momentum. तो angular momentum निकालने के लिए मुझे क्या चाहिए, पोजीशन वेक्टर, that r, so that is xi plus yj क्या, एंड सिमिलरली मुझे वेलोसिटी चाहिए थी, तो वेलोसिटी में लिख सकता हूँ that vxi क्या plus vyj क्या. So first I am calculating that x and y at time t equal to 0. So putting that initial condition, then I can put at time t equal to, at time t I can see that the displacement is this thing, right? So this is our first condition for this equation first. Similarly मैं ये condition use करूँगा equation second के लिए. So that means at time t equal to 0, again I can write that, again at t equal to 0, or you can write this way at t equal to 0. तो जो मेरा y है तो वो किसके बराबर बनता है y0 के बराबर. So that means initially when the particle is at rest, so we have some displacement along y direction. So it has some displacement and that displacement is y0. So it is initially when it has some displacement, so it is at some displacement at a distance of y0 from origin. Okay. So let us use this condition in equation second. तो जब मैं यूज करूंगा because at t equal to 0 हमारा y0 के बराबर बनेगा. So this is y0 will be equal to, so at t equal to 0, so ये term 0 बन जाएगी. So that means I can write that c equal to y0 because cos of 0 equal to 1 again. So c equal to y0. So when I use this in this condition, so that means I can write that y will be equal to, so let us substitute that at t equal to 0 y equal to y0. So y0 equal to c. So c equal to y0. So y equal to y0 cos omega t plus d sin omega. Is it okay? Because यहाँ पे मैं कुछ ये कंडीशन यूज कर रहा हूँ that at t equal to 0 हमारा c y0 के बराबर आता है. Use that value of c in equation second. So that means जो total displacement होगा, so that will be y0 because c equal to y0 and rest is same. So that means I have these displacement at time t. Okay, x and y. Now similarly, so I can write now the position vector. So position vector मेरा क्या होगा? तो जो मेरा position vector होगा, so that will be xi cap plus yj. So that is x equal to b sin of omega t, or we can do it later. So मैं ये कर सकता हूँ, but let us first we can write what should be our position vector. So let us first calculate the velocity component at time t equal to 0. So that means again I can calculate now the velocity. So velocity क्या होगा? Let us calculate now x component of velocity. तो जो इसका x component क्या होगा? So that means I need to calculate that vx. So that will be equal to x dot. So x dot क्या होगा? Because x is equal to this thing. So x dot will be, so I need to differentiate this. So this will be b sin omega t will be cos omega t and omega t will be omega, right? So this will be equal to b omega cos omega t, right? So now at t equal to 0, because so this is what I am calculating x dot. Huh? So at t equal to 0, so what is our velocity at that point? So question says that अगर मैं question की तरफ देखूंगा, तो I have at t equal to 0 जो मेरी velocity है vx is equal to v naught or vy equal to v naught, right? So I can use these. So at t equal to 0 जो मेरी velocity है vx or x dot, that is v naught equal to, that is v u, or you can write that v equal to v naught upon omega. So I can write it. So that means what's my vx then? तो मेरा vx क्या होगा? So vx will be equal to v naught cos omega t. So I can rewrite this as so because this at t equal to 0 हमारा जो v naught है, so that's equal to v omega, and I can write my x now. So what's my x? So x मेरा जो है, so that is equal to b sin of omega t. B sin of omega t, or this is equal to b equal to, you can write that b is equal to v naught by omega. So that's v naught upon omega sin of omega t. Okay. And my vx is equal to, तो मेरा जो vx यहाँ पे बनेगा, so that will be equal to v naught, because let us have a check, let's have a look. तो जो मेरा vx होगा, so what's my vx now? So because vx is equal to b omega cos omega t, so that means at time t equal to 0, so I can write that b omega equal to v naught. So that means dx will be equal to v naught cos of omega. तो मैं इसको मैं लिख सकता हूँ dx equal to v naught cos of omega, right? Because जो जो b omega आता है, so that's equal to because b omega equal to v naught. So this is v naught cos of omega. Okay. So that means I have now the x component as well as the x component of that x component as well as the velocity x component of velocity also. That is x and vx. Now I need to calculate my what's my vy. So I can write now similarly. So I can write what's my vy. So that's equal to y dot. So that means जो मेरे पास y था यहाँ पे at time t equal to 0. So the displacement is this thing. So I need to differentiate this. So when I differentiate it, so this will be, because I need to differentiate it with respect to time, so I'll get minus sign. So this will be minus omega y naught into sine of omega t plus, because differentiation of sine will be cos, so this will be d omega cos of omega t. So इसको simply differentiate करना है. That's it. So that means I can write my vy. So vy will be equal to, that's minus that y naught. So is it okay? Right. Y naught. Y naught omega sin omega t plus, and then it is d omega, huh? Right. D omega cos of omega. Okay. So that's, sorry. So is it okay? Right. That's right. Now let us put now at t equal to 0 now. So अगर मैं t 0 लूँगा at time t equal to 0, my vy equal to v naught. So again at t equal to 0, at t equal to 0, so my vy is v naught, right? So that means इसको मैं लिख सकता हूँ v naught equal to, so that is minus, okay, so that's right, but at t equal to 0 ये term 0 बन जाएगी. So I can have only do d omega will be equal to v naught. So this will be equal to d omega, because जब t में 0 होगा तो ये term 0 बन जाएगी only. So this is equal to 1. So d omega will be equal to v naught. So v naught equal to d omega, right? So that means I can use this d, value of d, in my displacement, y displacement, that is v naught upon omega. So that means we know that our vy equal to this thing. Sorry, y we have calculated. So y हमारा जो है, so y is this thing. So instead of d, I will write that v naught by omega. So that means I can write then my y equal to, so that is equal to v naught. Sorry, that's y naught. So y equal to, that is y naught cos of omega t, and तो d के बदले मुझे क्या लिखना है, that is v naught upon omega sin of omega t. Because let's have a look, because यहाँ पे जो हमारा displacement था along y, so that was y naught cos omega t, and d का वैल्यू हमने कैलकुलेट किया यहाँ पे. तो d का वैल्यू है that's v naught by omega. So that means instead of d मुझे वैल्यू लिखना है that's v naught by omega and sin of omega. Okay. So now we have calculated vy. So similarly I can calculate my vy from here. So vy will be equal to, so that we have already calculated at t equal to 0. So that is this thing. So instead of so I can write that this will be equal to minus y naught upon y naught omega sin omega t. Okay. So that is equal to, and d omega equal to, so d omega equal to, that's v naught. So plus v naught cos of omega. So this is all what we have. तो मुझे क्या चाहिए था, तो I need to calculate angular momentum. उसके लिए मुझे position vector r चाहिए था और that velocity vector v. So but that position vector has two components along x and y. So that means I calculated that x and y components. I also calculated that vx and vy. So now I have to simply, I need to substitute it in that equation, that L equal to that m into r cross omega. So I will get what's my total angular momentum, right? So this is okay. तो मेरे पास अब x भी है, so that is x equal to this thing, vx इसके बराबर है, and now y equal to this thing and vy equal to this thing, right? So that means let us first write what's my position vector from here. तो मैं position vector पहले लिखूंगा. What's my position vector? तो अगर मैं position vector यहाँ पे लिखूंगा, तो my position vector will be equal to, so that's xi cap plus yj cap, right? तो अब मुझे from my what I have done, so my x equal to v naught by omega sin omega t. तो ये मेरा x component है, so my x component is v naught by omega sin omega t I cap plus vy. तो vy equal to, sorry, y equal to, that is this thing. तो जो हमारा y है, that is y naught cos omega t plus v naught by omega sin omega t j cap, right? तो वही मुझे यहाँ पे लिखना है, so that is v naught by omega cos omega t plus that v naught by omega j cap. Okay, because this is our y and this is our x. Okay, so this is our r, and similarly I can write my velocity. So my velocity will be equal to vx I cap plus vy j cap. So my vx, so let's have a look on तो जो मेरा vx का वैल्यू क्या है, vx मेरा है, so that is v0 cos omega t and my vy equal to minus y naught omega sin omega t plus v naught cos omega t, right? So let us write my total v from here. So I can write my v as, so that is v naught cos omega t I cap plus, and there's minus sign then, huh? Minus y naught omega sin omega t plus v naught cos omega t. तो आप चेक कर सकते हो, you can check whether this is correct. So this is our vx and this is our vy. So we can check that our x is equal to this thing and our vx is equal to this thing and vy equal to this thing. So that's correct. V naught cos omega t. Okay. Now let's calculate what's my angular momentum. So angular momentum equal to, so angular momentum L will be equal to, that is equal to m into r cross v. So इसको मैं, so either I can write that in determinate form, write that I j k components. इसको मैं ऐसे भी लिख सकता हूँ that I j k and then write the x and y components here, x and y components here, and similarly vx and vy. तो यहाँ पे मैं x y 0 vx vy and 0 ऐसे भी लिख सकता हूँ, or I can, because we are already aware about this cross product between these unit vectors, so I can do it that way. So it's very easy, so you can do it. Now so let's have a look on this. When I take the cross product of this with this, so that means इसका cross product मुझे इसके साथ लेना है. Okay, so because when I take the cross, let us take first term, तो पहले मैं ये term लूंगा इनके साथ. So that means जब मैं v0 by omega sin omega t take it as cross product with the this term, तो यहाँ पे I है, I cross I equal to 0 because this is I cross I, A cross B, that is mod I mod B sin theta. So that means ये term 0 बन जाएगी. Now only term जो यहाँ पे survive करेगी, so that is when I take the cross product of this I term with the j term, right? So because I cross j equal to A, so when I take this cross product of this with this, तो यहाँ पे दो terms है, तो पहली टर्म क्या बन जाएगी? सो v0 बाई ओमेगा, यहाँ पे y0 ओमेगा है, तो ओमेगा और ओमेगा कैंसिल हो जाएगा, तो आई कैन राइट इट इज माइनस टाइम्स v0 y0. तो दैट मींस फर्स्ट टर्म क्या आएगी? So that is equal to m you can take out. So inside will be minus v0 y0 because यहाँ पे जो ओमेगा ये ओमेगा कैंसिल हो जाएगा एंड देन साइन स्क्वायर ओमेगा टी। तो ये मेरी पहली टर्म है जब मैंने इस टर्म का क्रॉस प्रोडक्ट लिया विद द फर्स्ट टर्म ऑफ दिस जे कंपोनेंट है। नाउ टेक क्रॉस प्रोडक्ट ऑफ दिस टर्म विद द सेकंड टर्म। तो जब मैं सेकंड टर्म यहाँ पे लूंगा तो दैट मीन्स आई कैन राइट दैट सो देयर इज सम तो कभी डॉट्स पड़ जाती है। So now take cross product of this with this. Again, this will be I cross j, that is k. Now v0 is this, so this is I can write that. So this will be equal to plus v0 square upon omega sin omega t, and this will be k cap. So this is clear because when you take cross product I cross j, तो दोनों term बन जाएगी because I am taking cross product of I with j. So this is I cross j, that's k. So this is the k term from here. Okay. तो ये मैंने पहली टर्म ली, राइट। नाउ अब मुझे ये टर्म लेनी है, टेक दिस जे टर्म ऑफ दिस और टेक इट इज क्रॉस प्रोडक्ट विद दीज टू टर्म्स। तो लेट्स हैव अ लुक ऑन द क्रॉस प्रोडक्ट ऑफ दिस विद दिस बिकॉज ये यहाँ पे क्या बन जाएगा जे क्रॉस जे, so that is equal to 0. So only this term is survive. So that means when I take cross product of j term with the I term, so that means मुझे क्रॉस प्रोडक्ट लेना है इसकी फर्स्ट टर्म इसके साथ। So that means this will be y0 v0. So it will be plus. You can write that it is v0 y0, and now this is now cos omega t and this is cos omega t. So this is cos square omega t. Now second term, when I take cross product of this with this, so this will be equal to plus. Now this is now j cross I, so that's minus t, right? So when I take here, so this is now this will be, or you can write here, तो मैं यहाँ पे लिख सकता हूँ because so इसको मैं लिख सकता हूँ यहाँ पे, ओके तो I can write it this way। तो ये यहाँ पे k क्या है because this is j cross I, so that is minus k, तो माइनस मैंने यहाँ पे रखा, so rest is same। Now when I take, because this is minus term, this is again minus term, तो ये बन जाएगा minus v naught y naught, and then you can take this common, it will be sin square omega t plus cos square omega t, so that is equal to 1। तो यहाँ पे बन जाएगा minus v naught y naught। now यहाँ पे अगर हम देखेंगे तो ये प्लस टर्म है तो दूसरी टर्म माइनस बन जाएगी बिकॉज इट इज माइनस टाइम इज दिस, तो ये दोनों कैंसिल हो जाएंगे। तो ओनली these two terms will survive now, and when I take them, so okay, let me write one more step। so I can write here my L will be equal to, so that is equal to m into minus v naught, so it is v naught y naught, तो इसको मैं लिख सकता हूँ, तो दिस विल बी माइनस m v naught y naught, so this is my total given, right? So that means under velocity and that cushion vector are in xy plane, so angular momentum will be along k cap along z. So this is our total angular momentum. So similarly, we can have many more problems on this Lagrangian mechanics, and we will do some problems in our coming lecture. Thank you very much.